Isa is a very, very talented developer, and I guess we'll hear about her work, especially today on the Murder game engine, which is really, really cool, a custom game engine that she and Pedro are working on their new game. Yeah, it's all really cool. I've played a lot of the game, or a decent amount of the game, the demo, and I've had a great time with it. And yeah, we'll hear more about all of that. Thank you, Isa.
Okay. Okay, so my talk is 9 secrets for a future-proof game engine. But really, it's about designing tools that scale in the long term. And by this, I mean just things that I learned while I worked with tools, being in my game engine, or just past experience. And before I start, I was just curious, how many here are programmers? Okay, cool. Of those people, how many of you have tried doing your own tool, or maybe doing your own custom engine, or tinkering with something? Okay. So this talk is very technical, but I try to keep it as approachable as possible, but just like keep it in mind, and again, I tried making it approachable, so I hope I did a good job. So who am I? I'm Isa. I worked 6 years at Microsoft with the Visual Studio Debugger team. So it's not that I worked using Visual Studio, I worked making the Visual Studio Debugger. So that was really cool. Like I own features like the hot reload in C# and just the expression validator and things like that. I started the Murder engine that I'm going to talk about 2.5 years ago. So it was like a side project that I did on top of my day job. And now, as a month or so, I'm full-time on Cold Blood Inc., just doing games. So that's been very cool. And obviously, I just love working with tools. So I just have a couple of disclaimers. Most of the tips here apply for a small team, so 1 to 10 people. Although I did learn a lot of them, as when I worked in Microsoft in Visual Studio, and it was like 100 plus people. So a lot of them apply as well. And I'm not saying any truth, I'm just saying from my experience. And you see a lot of the Murder game engine here, but this is not intended to be a showcase of the engine. It's just because when I tell things, I like to show examples. So I thought the engine would be a great way to show examples on what I'm talking. And also, I'm not here to convince you to do your own game engine. Like, I don't think this is a good idea for everyone. Although, again, I'm biased. I do think that making your tools or making your own thing can scale really well for a sustainable studio or like making future games. But this talk is not about this. But what I hope to do as well is just to prove you like a glimpse of what it would mean if you were to do your own thing or your own engine, what that entails. So the first thing that you need to do if you're making like your own game engines, absolutely make a game. Sometimes people don't want to make a game, they are more interested in the engine. But everyone who's using your engine will make a game. And I do think that the best tools are the ones that you also use yourself and you know exactly what to do, because you just want to start with whatever unlocks you. Like, you don't want to start like with a very like complex design that scales forever and do everything you ever want. Like, this doesn't really work. You just want like the base building blocks and just make little guys move around the screen. And yeah, that's the best way to start. And here I'll just show like for my engine, like in 5 days or so, I had like this amount of lines and I had a tiny prototype. And the whole idea is that have something that already does something. I think we did not have something that actually printed in the screen, but I was able like to open an entity and like add components, which would be used in the game later on. I think that was the idea. And then after 2 months or so, we had another prototype. So we always had something, but now we had another one. And this time we had another project. We have one for the editor, which is like more tooling, and the other just the game. And we had another for ECS. And I'll talk about more ECS later, but it's basically, it's a whole thing. It's like entity component system, and it's a way you can make games which are very cool and data driven, but anyway, it's just, you just have to think about it. Oh, it's just one of the implementation details of that. And after 2 months, it looks way more robust now. You can like move the position. Yeah, this is a board. I think I started working on prefabs. So you could place prefabs in the world. You had something. And then you have the actual game. I think they just move and then they would attack you. But you could have friends. Then it would attack the zombie, and yeah, it had some pathfinding, and then you die. But there was something there. And then 6 months later, and then we were still working on this game. It was the same game, but you can see a lot of work went through. And one thing that is nice about having like different projects like this is that you can see exactly what's going where. And I do think that just having something just for the editor is a good, like it's an absolutely amazing sanity check, because you can do all sorts of things in the editor project that won't ship in the game. So, and 6 months in, it looks more like this. So now, it's similar to the other ones, but you can see that it's more robust in some others. We had some Word editor. It's also prefab based, but we did a lot of things procedurally, so we didn't really need to do like fancier tools. And the game was more, like, it was the same idea. You were still a guy, like a little guy, you moved around, and then you could have friends. I think this is where you get your friend there. Okay, now you have a friend. And that's the procedural dungeon. At the time, we thought it was the best approach for this, and then we were going. I think there's a zombie there. Oh no, it's another robot, but it's an enemy robot. And they explode, and yeah, that was pretty much it. And then 6 months later, now what we did, that other game, it was just getting oversold. Like it was like a prototype. I'm like, this is not working. So we just scratched the whole thing, and then we started a new one. But we didn't lose anything, because I did a very painful process that I just took all the code, and then I just reused the things that I wanted to use as the engine. So now I have the murder engine and the murder editor, and then the ECS things here as well, base. And then there's game and game editor. And now we had a new prototype. But this was so good because I could just reuse, I didn't lose anything. Like we learned a lot, we did lose some things, but I think it was just worth it. And this was the game at the time. Now we had a fancier editor because we were no longer procedurally generating stuff. We were like, could drag around, and the game looked like this. You could move, and then now you could fight with your sword. Yeah. And then I think it's like 1.5 years, and then we are here today. And then most of the work here I did as a side thing. I was like still having a day job, but except for like as of a month ago or so. And this was the state. And now we have a prototype, kind of, sort of. We worked on something else on top of the other one. And now we have our game that's much more exciting and makes more sense for the team. But it's still the same structure here. So it's like murder editor. We have GUM, which is like the dialogue scripting language that I did as well. Just we have fancier dialogues. It was the whole thing. And then we have it, but it's here, right? And you can kind of see where the work is going, and I think it's just great. And like now this is the state of the editor. There's a lot more features. They have a little tween when you move. You can go to the prefab and still there. The colliders now make sense. You can just move them. Oh yeah, you have pathfinding, you have the story editor. And then the game itself looks like this. So this is our unannounced game, but it's more or less like it changed so much. But we could just always keep reusing the same tools, which I think was so valuable throughout the process. So like the takeaway from this whole thing is just the whole time that I was doing stuff, I was changing things, I was moving around. I was trying to avoid comparing myself with other more robust tools or other engines, I would instead just compare how far I went as compared like 6 months ago. And this would always help me keep going and doing like better and better tools. It just really helped me. And also, I do think that using other engines is so valuable because you can learn what people do, what approaches they make, what choices they did. So I didn't came from game dev before, but I worked with Pedro who used a lot of game engines. So he knew all the like nicest things to have, and he could just tell me, oh, we should do that. And these are the edge cases. I was like, oh, that's perfect, because I have to account this and this and that. So like the experience helps so much. So like even if you just want to make tools later on, I think everything that you learn, it will always help you. And then the second thing that leads me to, it's define your goals. So you just don't want to make like an engine or two, but don't know where it's leading up. I think that making your goals clear are so important to keep your focus. So I really think that your time is always your most valuable asset. So just knowing, like for example, if you have some very hard feature, and like let's say that you need to refactor the whole pathfinding system, and then you can say, oh, that's very hard to do. Or you can just say, oh, that will take me a week and a half. And then it's always like you're budgeting like your time, and you, okay, do I want to like buy 1 week and a half to do this? Is it worth it? So if you get good at estimating costs, that helps you so much. And if you have a goal in mind, that will help you to choose what to prioritize and do your trade-off in a smart way. So for example, for our engine, the first goal, like throughout the whole process was, okay, we want to make an engine good for game jams, because if we do it good enough for game jams, that means we can iterate fast, and that's exactly our goal. And I think like last year, May, we did this game for the Ludum. You drive around and then you have to write text messages while you're driving. There's two drivers. Yeah, it was great. It was great. Like with Davey, Pedro, Ryan, like we all had fun doing it, and we got a bunch of like good places in Ludum. So I do think, like it was I really think it worked out. And what was interesting is that I think at the time we went into some GitHub blog or like games of the month or something, and they thought we were using Unity, but it was not Unity. It was like our engine. But I do think it was kind of a compliment, because they thought it was like a well-established engine that could do all this polish and UI. And I was like, okay, like our engine actually achieved that. That's really cool. And just so you can have an idea as well what happens. So this graph here is just the start in GitHub. So like here's where it started. And then in May we shipped the Ludum game. And then in October-ish I announced as actual open source engine. And then I think I got first stage of Hacker News, and then it keeps going up. So what's next? So really, like our new goal is like shipping a commercial game. So we don't want like convince people to use it and like make it widespread. That's not our goal. Our goal is just to make a good tool, and we want to ship a commercial game. So every decision we make, every budgeting we make, it's towards it's like shipping our first commercial game with the engine. And also, another thing that's really important, on top of the goals, it's something that I compare like with design pillars in a game. That's something that guides you. So for example, for Murder Engine, we have something that's one-click setup. So what do I mean by this is basically, if you just like got the Murder Engine on your computer, I want it to work on just like one command, one click. You don't need to do fancier things, like you just click and it goes. And also, it's very programming first. So I don't want to do any black box, like you just push the button and then it's going to export. No, I wanted to have full visibility on your project and what's actually shipping. And also, I want to prioritize our team strengths. So like, especially for me and Pedro, like we code a lot. So it doesn't make sense to do things that for people that don't code, in the engine because we just code. So most of the coroutines, they're all C#, and we just do C# hot load, and it works great. And we integrate where needed, but a lot of the time we just try to keep in mind like where we are most strong with. And okay, just to show an example of what this means. So remember I said, oh, one plate setup, it works. So what does that mean? Like, it means something like this. Like, this is just the asset management. In the engine, like, it's very complicated. Like, every engine must have something very complicated, but it's basically where it ends up, and like, oh, there is like the editor project that inherits from the other murder engine editor, and then they all ship on this folder, and then when the game compiles, it pulls from here. Like, there's a whole thing. But then, like, after doing this, we can do things like, oh, we can just click a button and run the engine on Steam Deck, because all we need to have is just .NET, and then we are able to build the thing and have the game there and just edit stuff. So it really paid off in my case. And okay, the next one that I do think is very important for engines, never crash. And this is hard for me as well, because my first impulse whenever I see something bad happen is just like, you know, you control it, like you don't have to click that button when you're doing that. Like, why would you do that? Especially like working with other people or having other people use. That's my first impulse. But I think that's a bad idea. Like, people have different workflows. I don't ever push my own way of working on other people. I want like to accept and see, okay, you did that, okay. Like, a lot of the times they did something that I will do eventually for some reason. Like, I don't know, I changed, and then I just click that. And I think it's important to never actually crash in your face, so you're not annoyed or disrupted. And some ways of doing that is, for example, make it very obvious that something went wrong. So like here, I think like an image didn't load. So instead of just crashing, like we show this asset like, oh, error, like something clearly went wrong here on the atlas. And then we can know right away that something bad happened, and we can fix later if that's the case. Or just doing a lot of logs. You don't have to crash right away. You can just tell exactly with as much details as you can what went wrong, so you can later go back and see if you can fix it. Especially if like other people on the team, like someone who's making the sounds, they don't want to really care about this. They can just send this to someone that does the programming, and then I can fix that. Another thing that I don't see using as much as game dev is debug assert. So here is C#, but a lot of other languages have their own assert. And this just means like it's an area of the code that's only going to be executed when the code is compiled with debug binaries. And the game ships with release binaries. So this will never touch the game code because it's like under the assert. And it's really good just to validate assumptions. And someone reading your code, it could be like someone else, or even you like 1 year from now, like it's basically a different person, can just see, oh, okay, so these are the assumptions. So you didn't even need to comment anything, you just see the asserts, and then you can see all the assumptions made in that chunk of the code. Also something, this is just a treat, but this is very C# specific, but you can do things like color member name on the method, or color line number, and when you log that thing, it will say who called that from where, and you can tell right away. And this works like even with release binaries. It doesn't work for native AOT if you ship in consoles, but it will work on PC, and it's very cool. Another thing, I love everything that warns in compile time. So for example, we had someone which was nice enough to contribute to Murder after we went open source and added all this nice diagnostics analysis. So like, oh, this expects something like this. You should add that, and then you can know that before even compiling your game. It won't crash or not work in your face. Or really just anything like, if you use C#, nullables are so good. You should use nullables. They saved my life. We never have a null reference exception anymore because it's so good. Okay, for the next thing, I think you should make it fun, you know? Like, you're spending all your time there, you're like making all this effort. Like, if you're having fun, it probably means that your game is going to be a lot more fun too, because you're more creative, and more inspired, and it really reflects. So these are like some of the things we did. Like we have this little crow here. When it's loading, I don't know if you can see it right, but there's like a little crow animation when the engine's loading. And here as well, like in the dialogues, you like do a little twin, like it's so I'm usually here when I'm debugging dialogues, and I'm usually like kind of stressed out, but then I'm like, look at this, I'm like, okay, that's fun. Here as well, I love this. It's like you add thing in the map and then boop. And then every time that I add something to the map, I'm usually happy because I can just do that. I think this one as well, like we add messages to sprites, so like it emits a message on a certain frame. And then we can just do that, and you can review how the animation goes. And this as well. This was like when you're running a game, we had a debug option to see which sounds are being emitted. So we just do that by just showing the whatever messages we have from the last screen, and just showing that in the game. And it's such a creative way, because then we can even ship that as an accessibility feature, maybe for our game. So you can come up with ideas. And especially when adding content to the game, like you make it fun and like you want to add content because you have a good time. Okay, and for my next one is you only do things once they become a bottleneck. And that's something that's tricky as well. Because a lot of the people like overthink performance a lot. Like they want to do perfect at the first time. And this usually doesn't really work. Like the best way is always like, unless you have a lot of experience into what you're doing and you know you're gonna nail it, then it's fine. But like if you are really like doing a new thing and you're just guessing where the performance will go, you're usually like you don't get it right. Like just use a profiler. The fix is almost always very boring. I think that's what people don't like because it's always boring. Like it's always, oh sure, I have, like I don't know, it's just not a good time, but it's what helps. Like I really think that a lot of the time costs. Like we have strategy A and B, or you can just analyze. Like for hours, what's the best one? It's usually cheaper just to implement something and see where it goes. And also, something that I did a lot is to never profile debug binaries, because if you're profiling with the debugger like binaries that used to like debug and do the asserts, there might be a lot of code that won't even ship to the game, so you're just looking at the wrong thing. But I do that a lot all the time. And this is just like another thing, just to show more examples of like the time that I've spent fixing performance stuff. Most of the time, I just needed to cache something. Okay, let's just cache and not ask all the time that I want something. The other time is just like half of the times like, can we just not call that? Can we just not call that entirely? And you're like, oh, yeah, I think so. And then you just not call that, and then you saved all the things. And I think just like in the little fraction, it's like, oh, okay. I need to refactor the whole thing. But it's so tiny and it's so rare that I don't think it's worth like stressing out all your time just for the little thing. And again, just because I see a lot of people talking about profilers, but they never talk about their tools. So I'll just sell like the tool that I use. So it's Purview. You can just download, I think it's open source, and then you have your ETL thing, you point to your executable, and you just profile, and the UI is really bad. I usually get so sleepy looking at this, and like it's already kind of boring, like looking at this, but it tells you all the things, like it tells you the methods, the time spent, and then I can say, oh, okay, I can optimize this, but then it will cost, okay, I'll save like half a second. Is it worth saving half a second here? And you can make like very like informative choices. And like another thing we did, this is more fun, like we did in our game is like, since we use the ECS thing, it's very data driven, so we can see all the systems like this, and we can see the amount of time they spent on each system, on how many entities are being run towards each system. So like for example, here are the fixed updates, these are our reactive systems, these are the renders. And one nice thing about the ECS as well is that you can just turn some of them off. Like here, just turn off all the sprite things, and then the game is working fine. And this is a really cool way of performance as well, because then I can just see, okay, if I optimize this entire system, like it's not even executing, like will that have any gains? And such a quick way to just validate that. And also, the whole thing about like only doing one system, it also applies to tools. Okay, but as a rule, we only automate tools after hitting it at least 3 times. So if you just did it once, it's not certain to be a tool. But if we did it more than 3 times, then it's definitely a good time. And we will just reuse the tools forever. Like in the next games, we'll use that. So it's such a good time investment, in my opinion. But there's sometimes we break this rule. It's whenever we notice we didn't do something cool to the game or creative because it was too bureaucratic. Like, oh, I would love to add this little effect here, but it's too much work to put it in, and then that's like a red flag. Let's try to make a tool to make that easier. Like some examples on things that I did only after, that's a problem. It's like hot reloading the sprites, like based on the file that you just edited. Or like shader as well, you added the shader code, and then you want to see in the game right away, like in Alt Tab. Something like even like save files for a game, like you just get the zip folder and then just drop in the editor. I would just unzip every time. I was like, okay, I'm doing this a lot. Or Ctrl-Z, and this one took 2 years. I didn't want to implement that, it's boring, but it took a long time. And then I was like, okay, the things are getting too huge. I should do a Ctrl-Z. And then we did it. And for the 6th one, he said you want to scale things horizontally. And what do I mean by this? So first, I'm very biased on this because of the whole ECS thing that I keep talking about. Like the whole ECS is like entity component system. It doesn't fit on the spot to explain what it is, but you can look it up later. But I can just talk about it a little bit. It's basically a data-driven approach. So you separate data from systems which have all the logic. So you can change the logic. The data is still there, it doesn't change. And I think that's the beauty of it because you just have the data there, so you can just scale things and they don't go this way, they go this way. If it makes sense. So like some examples, like I'm not the only one saying this, like on the way 2, they did a blog post. Very cool. They say, oh, ECS framework, they did it with ECS. It was like our favorite gameplay programmers thing. Because it made their life so much easier. And you can clearly see, like, on the way 2, you can see, oh, this is very ECS. Like, the things that you can pull it off, that's really cool. And, the side effect from that is that you have a lot of files. So just in the Murder project, we have more than 1,000 files, just files, not classes, files. And also for the game. And that's one drawback, but we can just search things so quickly. And after you have like a pretty tree, like it's not really an issue. Oh, also, another thing to make it like kind of like to actually scale that and not be a lot of work is you can generate code. And I did this after realizing that it was a bit of a bottleneck in performance. So I just generate code for every asset added in game. And if I just remove an asset, it's fine, like it's generated anyway. And it was really useful. Oh, another thing that you can do, like if you scale things horizontally, it becomes very modular. And this is like someone from like our murder Discord, they just added murder on top of Godot. And I don't really know why. I usually don't ask why, I just like help them to do the thing. But I think it's so cool, like they want to work on top of Godot, but they like the engine, and they could just do that because things don't really depend on one another. It's not like the library that I used. It's more like the data, so they could do that. So it's all about flexibility, really. That's the whole point of scaling horizontally, because you want to quarantine your weird code, but you want to do the weird code, because then you can quickly see if things work or not. Because maybe you want to just try something in the game and see if it's fun or not. And that just leaks a lot of memory, but that's fine because you're just seeing if it's really a good idea or not. And another quick example is just, for example, I have coroutines in the game, so it's kind of similar to Unity stuff, but I can just like wait for a few seconds and then do something, and that's something that I was able to do. But like I basically created something that have logic inside a ECS component. And that's illegal. They don't do that. And I did it, and it's fine because it's contained in this system. And it's like, I don't know, it's not leaking towards other components, it's this one component. So it was really work for me. Okay, I'll also do a talk on Fluentd and just covering more of this, like talking about other ways you can modularize your code. So that would be fun as well. So I just added this one here. Okay, for the next one, you want to basically abstract implementation details. So what do I mean by that? You can pick your battles. So when you're doing tools, engines, you don't have to re-implement everything yourself. You can if you want, if that's your thing. But remember, like I have a goal. My goal is to ship a game. And then if I re-implement everything, I would never ship my game. So I can just pick my battles. Like I don't have to, I get just to implement things that I found fun. And I have some examples as well where I did that. So for example, writing dialogue, I use VS Code because I was like, okay, I don't think I can do a better job in a text editor. I should probably just use another text editor and then just hot reload that, whatever, and just use that in my engine. But I do my best to integrate the engine with it. And then it just works really nice. Anyway, the video is not playing, but this one is also for like a sprite. You can also just edit things, and then it will show up on the editor as well. And again, like we are not implementing a sprite, like we can just like use the thing and then hot reload in the game. Another one was fmod integration. Again, we are not implementing fmod. I think that's out of scope. And then but we make like really nice tools with it. So like we have the engine, we pick up the events here, we can choose. And then we have this thing that is like a debug mode, and then you can ask like proximity. There's a very like sound of the river. And also this applies to libraries as well. So for example, in blue here are libraries that I use for the engine. So we have like SDL, FNA, IMGUI. They're all libraries that I use to do things. So I don't re-implement IMGUI, like it's fine, I can just use it for the editor. But if you're using, you can also use like box2D if you want to use physics, or you can just use a 2D level editor and not do the whole level editor yourself. And that's just a nice really way of just, okay, I can just offload this whole work of rendering to someone else and I can just consume that, but I get to draw the line. And another thing that I do as well is always prototype, and then implement, and then refactor. So whenever I want to do something new, I always spend some time just studying the best industry approaches. Sometimes I already have experience, so that you can just implement right away, but usually I just spend time, okay, these are all the games that I like. They do similar things. What do they do? And then I can just prototype a lot of random stuff, but in a separate Hello World project. So that's why it's a very good idea to just make something very easy, like if you do your own engine, like do a very simple Hello World project, because then you can just switch that. You just use the same infrastructure, test your idea, and see if it works or not. And really, like, just not overthink too much about the design. That's the thing that I like about just prototyping and then refactoring. Because a lot of the times your idea, it might just be not fun, it might just have really like deep technical blocker. So you want to first try it out before putting your whole game and changing the whole thing in your game to see if it works or not. So some examples of where I did this, like, because it's not always a great idea to not prototype on your game directly, but in some cases it is a good idea. So like, for example, when I was designing the coroutines that I mentioned before, I tried first in a separate project, see if they did the things I wanted to do, if the design looked nice enough, and then I switched to implement the whole thing in the game. When I was creating the custom dialogue language, I was doing a lot of tests, studying a lot of existing libraries, seeing what they liked about them, what I didn't, and I also had fun doing it, so that's why I did. Otherwise, I would just use an existing one. And then I was able, okay, it does what I need here, roughly. I think it's worth just using that. when I was refactoring serialization to use star generation, because it was using reflection, and then I needed to star generate all of that, and it was a lot of work. But before doing that, I needed to see if it covered all my edge cases, and that's why I just tested out. Making the engine native compile, which is like some detail for just shipping to consoles, but that was a whole thing as well. When I changed from, because they use FNA, right? But before I used monogame, and at some point I was like, okay, I'll switch to FNA, and then that was also a whole thing. It was not that amount of work, but it was something as well. So that's another example that just prototyping first and validating if that makes sense helped. And for my last one is you don't want to trust other people's advice. Because most people giving advice on their internet, they didn't actually ship a game. So they're just saying stuff. They're just like putting all these rules, like you shouldn't do that. And like, why? And like, no. And like even advice from experienced devs, a lot of the times it doesn't really apply to you. They're saying from their experience, but your might be different from theirs. And really, I really do think that selectively ignoring advice is how you can innovate, because you want to do something new, and people will say things about that they usually already know, they are familiar with. But if you're doing something new, people are not familiar with it. So usually, like, that's how you innovate. And let's say it even like everything went wrong, it's fine, because it's all about the journey, you know, like you learn. And then you can just use what you learn and like, oh, okay, that they say it was a bad idea, it is a bad idea, and then you don't do it anymore. But now you know why, and I think just learning why helps you a lot going forward, and it was really worth it. Okay, and this is the recap for all the things. Make a game, goals, never crash, and all that. And this is pretty much all I have for this talk here. And that's it.
Thank you, Isa. We have time for about 2 questions. So if you got a question, put up your hand first. Oh man, you covered all the things.
Great talk. Thanks.
Thank you.
Why did you call it the murder engine?
At the time, there was a lot of different reasons, but at the time, you're like, okay, we're making a video game. In video game, like you do like murder like stuff. It's like it's a fun, you know. But also like we later on like readapted and put like a little crow, so it's supposed to be a murder of crows. But I don't know. I think so. Yeah, that's it.
Well, thanks.
Hi, this is a great talk.
Thank you.
I just wanted to know what kind of motivated you to make your own engine? Was it something specific for like your game that you couldn't find in other engines, or was it just the love of making tools and having your own tools?
So I think at the time I just wanted to do something with Feather, and then I really liked C#. And then I was using all these engines. I was like, why is this C# outdated? And then I was finding all these spots. I was like, why they're doing this? I think we can do something better on this part here. And then we just, okay, let's do our own thing. Like it's not so far-reached. And then I think that's why, really. And then it just, like all the transparency, I really love just looking directly at things and being able to be flexible.
Great, thank you.
We got time for one more. Oh, sorry. Saw this one.
Yeah, I can make it quick because basically with what I saw there when it comes to like the hot reloads and stuff like that too, and then like I know you're mostly working on 2Ds, and then of course there's 3D engines like Unreal that are already innovating. So have you also looked at 3D engines for innovation in the sense of, say, even just simply offering like more like blueprint scripting, for example, as a kind of a quick fix method as well?
So I don't have a lot of experience in 3D engines, but Pedro does a lot. So like all the time, I think he did a lot of the Doom engine, which we did steal a lot of ideas. But I haven't looked at more like robust, like Unreal engines, just because like our focus is just a 2D pixel art game. That's what we want to ship, so that's why like that's our focus for now.
Wow.
Me, that's fantastic. What went into making it open source? Like, what the decision to make it open source? I guess that's.
I think my main thing, I always want to make tools available. Like, I don't like when people just keep the knowledge and it's like, okay, you can just say the thing. Like, they want it to sound, a lot of times people make it sound more complicated than it really is. And I don't know, I think it's just a nice way of like giving back. And I do have a lot of help as well. So people contribute, they contribute the diagnostic stuff or even like some localization features. So and just seeing people, like, people test it a lot, especially in weird Linux distributions. And then like we use mostly like Windows in day-to-day, but it's cross-platform, so we can, like, it's a nice way to just test and see if it's working. So I think it's like a mix of like having people contributing and just like giving back and making things available.
That's great. That's very cool.
Okay, thank you, Isa.